This is lesson 11.8. It's about binomial distributions, and by the end of this lesson we should be able to find binomial probabilities by using binomial distributions. First of all, a binomial experiment is one that is made up of Bernoulli trials. Bernoulli trials are ones that have all four of these characteristics. First of all, there is a fixed number of trials. So let's say we're flipping a coin. We'll give that as an example. To be a Bernoulli experiment or a Bernoulli trial or a binomial experiment, we have to say ahead of time how many times we're going to flip. So let's say we flip the coin 12 times. That would satisfy this first condition. Each trial has two possible outcomes, success or failure. In order for one of the outcomes of the flip of a coin to be success or failure, we have to define success. So we're going to say that heads equals success. And so now we have two possible outcomes. Heads, which is success, tails, which is failure. Third condition, the trials are independent. This you know because each time you flip a coin, it doesn't matter what happened on the previous flip. The next flip is a whole new chance for it to land heads or tails. So every trial on the flip of a coin is independent. And fourth, the probability of success is constant throughout the trials. When you're flipping a coin, the probability of getting heads, we know, is 1/2. So flipping a coin would be considered a Bernoulli trial or a binomial experiment. So if you have a binomial experiment, you can calculate the probability of any certain thing happening using this formula. The formula is pretty complicated, but once you know what all the variables mean, it simplifies things a lot. So first of all, n is the number of trials. So let's stick with the coin flipping thing. We're going to flip a coin 12 times. R is the number of successes. And you'll notice that R is in this formula here, here, and here. So if we're flipping coins and I need an R there, I would ask, what is the probability of getting, out of 12 trials, what's the probability of getting 6 heads? So using my formula, N is 12 and R is 6. Next, we need to know what P stands for. P is the probability of success. So for flipping coins, the probability of getting heads we know is 1/2. The R that we have here will be the same number we have here. So we're looking for 6 successes. Q is the probability of failure. So if the probability of getting heads is 1/2, the probability of not getting heads is also 1/2. And n minus r would be the number of times that we expect to not get heads. So if we get 6 heads, that means we expect to get 6 tails. So that's how you would use the formula. Okay, so here's an example. As a part of a promotion, a store is giving away scratch-off cards. Each card has a 40% chance of awarding a prize. Suppose you have 5 cards. Find the probability that exactly 4 of the 5 cards will reveal a prize. First thing we're going to do is check and see if it's a Bernoulli trial or a binomial experiment. Do we have a fixed number of trials? And the answer is yes, because we have 5 cards. Do we have success and failure? And the answer to that is yes. A success would be one with a prize. Third question, does the probability of success remain constant throughout? And it said right here, each card has a 40% chance of success. So P is 0.4. And finally, we need independent trials. And there's no reason to suspect that if you get one 40% off, that the next one has any different chance of, no, if one card has a prize, there's no reason to suspect that the next one would have any different probability of being a prize. So we are looking for the probability of 4 prizes out of 5 trials. So using our formula, n is 5, the number of successes we're looking for is 4, probability of success is 0.4, and this r value up here is the number of successes we're expecting. Probability of failure would be 0.6, and the number of failures would be 1. If we have 4 successes, we have 1 failure. That's how we would set it up, and we would get a probability of getting 4 prizes is 0.0768. Okay, so we know how to find a binomial probability. We still need to know how to use a binomial distribution, but that we're going to do in class. So that concludes lesson 11.8.